All right, everybody, welcome to Math with Grace. Today we're going to be going through Algebra 2, Book 1, Lessons 6 through 10. One thing I forgot to mention in my intro video that we are going to start needing from this point forward is graph paper. You can probably get away with it for a little while, just kind of sketching your own graph, but it will be useful in the future to acquire some graph paper. I will bring some to class Friday so that everybody can make use of it. All right. Lesson 6 begins on page 23 and it's titled Equations. And it tells us here that an equation is an algebraic sentence that says two mathematical expressions are equal. To solve an equation, we simplify it until a variable is alone on one side, usually the left side, with an expression or a numerical value on the other side. And to get started on that, we want to look at some of these properties of equations. The first one is the addition property. If A is equal to B, and then we add the exact same number to both A and B, then they're still going to be equal, right? If 1 is equal to 1 and we add 5 to both of them, 6 is equal to 6. Okay, that's all that is saying. The multiplication says that if A is equal to B and we multiply both A and B by the same number, C, they'll still be equal to each other. If 1 is equal to 1 and we multiply them both by 5, then 5 is equal to 5. Okay? That's how those two properties work. So let's take a look at some of these examples here. Example 1 is 5x minus 3 equals 52. That's our original equation. Now we need to remember what we do on one side of the equal sign, we have to do on the other side of the equal sign. And our goal here is to get this x by itself. So the first thing we want to take a look at is this outlying number, right? This -3 or -3 is affecting the x. So to get rid of this -3, we're going to do the opposite and we're going to add 3. 3 is being subtracted. We want to do the opposite and add 3 to both sides. So these cancel. -3 plus 3 is 0. And then we add 3 to 52 and we get 55. Now at this point, we're at this part of the equation. I don't want to cancel it all out. I want you to be able to see it, right? We're at 5x equals 55. That's not going to work for me. So here's where we're at right now. 5x equals 55. They kind of just went 2 steps at a time, but I want to break it down. I know this should be review, but let's break it down for now. Now, 5 is being multiplied by x, and we're trying to get this x by itself. So if 5 is being multiplied by x, we're going to do the opposite and divide both sides by 5. When we divide, 5 over 5 is the same as 1. So that's why they cancel. It's not like they just disappear. They just become something different. 5 over 5 is 1. 1 times x is just x. Okay. 55 divided by 5 is 11. So now we have two expressions. The variable alone by itself, that was our goal, equal to some other expression, in this case, just the constant 11. Sometimes it'll be another variable, but in this case, it was just a constant. So taking a look at example 2, this one's a little bit more complicated because we have to distribute this 9 through the parentheses. And because we have a variable on both sides of the equation, but it's nothing we can't handle. So 9 times x is 9x. 9 times a -2 is 18. The 3x on the other side was not affected at this point. Now, there are two variables, one on each side of the equal sign. What I like to look at is which variable is larger. Okay, the 9x is larger than the 3. So we're going to move the 3x. This is an Algebra 2 class. So this is how I will be doing these types of problems in class. And I feel like you guys should be mathematically skilled enough, or you will be soon, to take this in one step. So we need to combine these x's. 9 is the biggest one, so the 3 needs to move. on this side of the equal sign, the 3 is a positive. So to move it, we need to do the opposite and subtract 3x from both sides. We want to also move this outlier because, again, we're trying to get the x by itself. Here it's being subtracted from our variable, so we are going to do the opposite and add it to both sides. Ooh, almost ran out of space. 3x minus 3x is 0, so it's canceled. Negative 18 plus 18 is 0, so that is canceled. So we're left with 9x minus 3x, which is 6x's, is equal to, here's my equal sign, right? It needs to come down. And only thing left on this side of the equal sign is an 18. All right, that's where we're at. Now, 6 is being multiplied by x. Our goal is to get the x by itself. 6 is being multiplied by x. We want to do the opposite of multiplication, which is division. We're going to divide both sides. 6 over 6 is 1. 1 times x is x. 18 divided by 6 is 3. All right? Beautiful. Let's turn the page. Here at the top of page 24, it tells us that if a variable has a coefficient that is a fraction, we can remove that fraction by multiplying both sides of the equation with the reciprocal of that fraction. So looking at example 3, 2/3 x equals 12. This is a very common, it's a very common thing to have fractions in these problems. So 2/3 is being multiplied by x, right? And that is then equal to 12. Instead of doing the opposite, because it's a fraction, we kind of do the opposite in the fact that we're going to multiply by the reciprocal. When we do that, this 3 over 3 becomes a 1, this 2 over 2 becomes a 1, and we're left with just x by itself. And then to solve this part, you can take 3 times 12 divided by 2, or you can reduce the 2 and the 12 to a 6 and a 1, right? And then 3 times 6, however you like to solve those kinds of fractions. As long as you're coming up with the correct answer, we're golden, okay? Looking here, then it says if there's a fractional coefficient on both sides of the equal sign, we multiply by the lowest common multiple of the denominator. So looking at example 4 here, we have 2/3 x equals 1/2 x plus 1. Well, 2/3 and 1/2 cannot be added, right? They're not common fractions. They don't have a common denominator, so we need to find the common denominator. Easiest way to find the common denominator is to pick the largest denominator, in this case the 3, and figure out multiples of it until they are this, they have a common, they're the common denominator, right? So 2 does not go into 3 evenly, so then we take 2 3s. 2 3s is 6. Does 2 go into 6? Yes, because it took the 2 3s to get there, right? So 6 is our common denominator. And so we multiply both sides of the equal sign, not just this term, but the entire expression, the entire expression on this side has to be multiplied by 6. This is probably where the most errors come. People modify this, but not this one. I like to write it like this: 6, 6, 6, okay? Each one is being multiplied by 6. That way I don't leave anything behind. You could write it like this totally. I mean, it's the exact same thing. You have to distribute through, right? Then you solve it just like we solved any of those other problems. Okay, so let's take a look at some of these problems together. All right, so I grabbed a sheet of scratch paper because there's really not a lot of room in the book. Algebra 2, Book 1, Lesson 6, page 24. Here are 3 of the problems that we're going to go through. Remember, if you use a piece of scratch paper on your quizzes and tests, please include that when you turn them in so that I can see your work. All right, so number 3. 7x minus 3 equals 11. Trying to get this x by itself, we're going to deal with this outlier, was what I call them. It's not like a technical term mathematically, it's just what I call it. So 3 is being subtracted from our 7x. We are going to do the opposite and add a 3 to both sides, okay? Negative 3 plus 3 is 0, so it cancels out. My 7x was not changed, so it comes down, is now equal to 11 plus 3, or 14, okay? Now, I'm trying to get this x by itself. 7 is being multiplied by x. We are going to do the opposite to cancel it out. We're doing the opposite and dividing by 7 on both sides. 7 over 7 is 1, so they're canceled out. X is equal to 14 divided by 7, or 2. Okay? Number 4. Here we have 20 over 3x equals 5. Fraction, we want to multiply by the reciprocal. Okay? So we're taking 3 over 20 on this side, and we're multiplying by 3 over 20 on this side. All right? 3 over 3 is 1, canceled. 20 over 20 is 1, canceled. X is equal to, now, again, you could take 5 times 3 and divide it by 20. Do not write a decimal, okay? I don't know if you're used to doing that. This problem does not contain a decimal to begin with in the original equation, so you shouldn't be writing a decimal answer. So you could multiply 5 by 3 and put that over 20. You can reduce and then multiply. However you want to do it. I'm going to reduce because 5 goes into 20 evenly. 5 goes into 5 one time. 5 goes into 20 4 times. So my answer is 3 over 4. If you had multiplied, you would have gotten 15 over 20, which then would have reduced to 3 over 4 anyway. Okay? Please make sure you're reducing your fractions. Algebra 2. Got to be doing all this stuff. All right, number 5. 1 over 12x is equal to 31 over 3. Because these two things are equal, there's one term on this side and one term on that side, just like we had on number 4. We don't need to find a common denominator, okay? It's only when they had more than one term on one side of the equation that we needed to find a common denominator. So again, in this case, we're just going to multiply by the reciprocal. And here, because the reciprocal of 1 over 12 is 12 over 1, or just 12, any number over 1 is just that number, we're just going to multiply both sides by 12. 12 over 12 is 1, so then they cancel out. Now you could multiply 31 times 12 and divide it by 3, but I'm going to cancel first because I don't feel like getting a calculator out. 3 goes into 12 evenly. There's 1 3 in 3. And there are 4 3s in 12. 4 times 1 is 4. 4 times 3 is 12. And there is our answer. X is equal to 124. All right. Next problem is number 6. We have 10x plus 3 times the quantity x minus 5. Oops, sorry. Equals 9 times the quantity x plus 3 plus 10. So first thing we need to do is to distribute these couple of terms here. So we have 10x, 3 times x is 3x, 3 times a negative 5 is a negative 15. 9 times x is 9x, 9 times 3 is 27 plus 10. Now we need to simplify both sides of the equation. 10x plus 3x is 13x. And then we have this 9x, which isn't changing, and then 27 plus 10, or 37. All right, now both sides are as simple as they get. We need to combine them. 13x is larger than 9x, so the 9 is going to it needs to move. Here it's positive. We are going to do the opposite to move it and subtract 9x from both sides. Remember, our goal is to get the x's by themselves, so we have to handle this outlying number. 15 is being subtracted from our variable, basically. We are going to do the opposite and add 15 to both sides. All right, I like to do it. Algebra 2, we're doing it in one step. 9x minus 9x is 0, so it's gone. Negative 15 plus 15 is 0, so it's canceled. 13x minus 9x is 4x's. That's equal to 37 plus 15, or 52. Okay? Now, 4 is being multiplied by x. To cancel it, we have to do the opposite, and that's divide both sides by 4. 4 over 4 is 1. So x is equal to 52 divided by 4, which is 13. x is equal to 13. Okay, taking a look at number 7, we have x over 2 is equal to 2 over 3. Okay, here there's a couple ways that you can solve this. I'm going to kind of write two things here. You can think of this as 1 over 2x is equal to 2/3. All we did was pull the x outside of the fraction, just like it was on these problems. Okay, this could have been written as x over 12 or 20x over 3. We're just setting the x on the outside. Okay, as long as it's in the numerator. If it was in the denominator, we couldn't do that. But since it was in the numerator, we can. All right. And then we could solve this by multiplying both sides by 2, which is the reciprocal of 1/2, right? And we would get x is equal to 4 over 3. That is a perfect answer. You do not need to change that to a mixed number. 4/3 is fine. I know it's improper, right? But that's it. I am comfortable with that answer, okay? Or the other way we could solve this, since we have a fraction equal to a fraction, this becomes a proportion. And when we have proportions, a fraction equal to a fraction, we can cross multiply. And when we cross multiply, we get 3x is equal to 4, right? X times 3 is 3x, 2 times 2 is 4. Now, 3 is being multiplied by x, so we're going to do the opposite and divide both sides by 3, and we get x is equal to 4/3, all right? Either way, we got to the same answer because we did the math correctly. You can solve math in a couple different ways. Usually there isn't one exact way to solve something. So if you feel more comfortable doing this, then go for it. If you want to, in this case, fraction equals a fraction, right? This is a ratio and a ratio. Together they become a proportion. We can solve it by cross multiplying. However you're most comfortable doing it, okay? As long as we have the same answer, correct answer, we're good. All right, number 8. X over 3 minus 3 equals 5 over 3. All right, first things first, because we have a whole number here and a fraction here, what we're going to do is we're going to get rid of the fractions altogether. They have the same denominator, so all we're going to do is multiply each term by that 3. Now remember, this negative belongs to this 3, so we want to keep them together. So here my 3's cancel because 3 over 3 is 1, and I'm left with just an x. 3 times negative 3 is a negative 9. Here my 3's cancel because 3 over 3 is 1, and I'm left with a 5. So now I have x minus 9 equals 5. We've gotten rid of the fractions altogether. But we're still trying to get this x by itself. Our outlier here is being subtracted from our x. We're going to do the opposite and add 9 to both sides. Negative 9 plus 9 is 0, gone. X is equal to 5 plus 9, or 14. Okay? So that is how we work through these problems that they've given us so far. Go ahead and finish the rest of lesson 6, and I'll meet you for lesson 7. Lesson 7 begins on page 26, and it's titled Identities and Contradictions, Literal Equations. And it says here, occasionally an equation is true no matter what value is assigned to the variable. And these are called identities. It's because one expression can be replaced by the other. And these identities can't be solved like conditional equations because they result in 0 equals 0. You don't see these very often because it's kind of a waste of time, but they want to cover it. Example 1, 2 times the quantity x plus 1 equals 2x plus 2. Well, that is a very true statement, right? If we were to distribute this, we see that 2x plus 2 equals 2x plus 2. If you were to continue solving those, even though they are identical identities on both sides, right, you would end up with 0 equals 0. I don't suggest doing all that because it's a waste of time, right? We just need to identify these identities and see that they will be 0 because they are exactly the same. For example 2 here, it says some equations have no solutions, and these are called contradictions. So looking at example 2, if we were to solve this problem, as you can see that they did here, you get 4 is equal to -6, which is an obvious contradiction. This problem is not solvable. It doesn't actually have an answer, okay? And that leads us to literal equations. And it says literal equations are equations with more than one variable. It's pretty simple to understand. Here are a couple examples. But we can use these literal equations to solve all kinds of problems, but sometimes we have to reorganize them. So for example 3 here we have distance equals rate times time, but they want you to solve for time. Say we're doing a story problem and we want to know the time, but we're given the distance and the rate. The equation that we know is distance equals rate times time, so we just solve for time the same way we solved equations in the last one. We want to get the t by itself. T is being multiplied by r. So to get rid of the r, we need to divide both sides. We're doing the opposite of multiplying. We're dividing both sides by r. Here they cancel. R over r is 1. So we have t is equal to d over r, right? Time is equal to distance over rate. It says literal equations can make certain solutions easier to find. Example 4, what is the diameter of a silo if its circumference is 62.8 feet? Remember, the word circumference is walking around a circle. Okay, if you were to walk around a circle, how long would it be? The circumference. Okay, well, their circumference here equals perimeter times diameter. And then they solved for it's not perimeter, sorry. That is supposed to be pi. They've got a they have an error here. I try to catch all these errors, but this is an error. So, sorry for that space out for a second. Usually P stands for perimeter when we're talking about math. But here, this is supposed to be a pi. I got to grab a pen. All right. Circumference equals pi times the diameter, which they have actually written right here, right? And so if we're trying to solve for diameter, pi is being multiplied by diameter. So we're going to do the opposite and divide both sides by pi. And so we get that the diameter is equal to the circumference divided by pi. Now, using that information that they gave us, that our circumference is 62.8 feet, we could divide that by an estimation of pi, 3.14, and get an estimated answer of about a 20-foot diameter. Okay, so let's take a look at some of these problems. I'm not going to do 1 through 6 with you. They want you to write identity to label identities, or contradictions to label contradictions. And then it says solve any conditional equations. We're just going to cross that part out. You don't need to solve any of those for 1 through 6. Just label which is which, basically. But we're going to do some of these other problems together. But I'm going to get a piece of scratch paper. All right, so in this first section, they just want us to solve each of these equations for a specific variable. So for number 7, we have w plus x plus y equals z, and they want us to solve for x. Here's my x right here. W is being added to x, y is being added to x. So basically, we're going to do the opposite of those actions, and we're going to subtract a w and a y from both sides. Those become 0, and I have x is equal to z minus w minus y. Okay, pretty straightforward. I'm not going to do number 8 with you. You can do it on your own. We kind of did it already in the example. So let's take a look at number 9. Area equals base times height. They've got a little a. I prefer capital. It really doesn't matter so much, okay? Area equals base times height. They want us to solve for height. Here, our base is being multiplied by height. To cancel it, we need to do the opposite of multiplication, which is division. B over b is 1. So now I have my height is equal to the area divided by the base. Okay. Number 10, we have the perimeter formula. Perimeter equals 2 times the quantity length plus width, right? 2 lengths, 2 widths. We need to solve for w, for width. To do that, we have to distribute So the perimeter is equal to 2 lengths, and I use this like cursive L because I think just like a lowercase l, you could use a capital L, I guess. Sometimes I do that too, but it's the lowercase l is kind of confusing to me. So, and then 2 times W. I want to be very clear. Remember, we're solving for the width. We need to handle this outlier first. It's a positive 2L, so we need to do the opposite and subtract 2L from both sides, okay? 2L minus 2L is 0, so on this side we have the perimeter minus 2L is equal to 2W. Well, 2 is being multiplied by W. We need to do the opposite and divide. Now you can do this in 2 ways. You can divide the whole thing by 2, or you can divide each individual part by 2. So you can divide the P by 2 and the 2L by 2, okay? Here my 2's cancel. 2 over 2 is 1, so I'm left with the width is equal to perimeter divided by 2 minus, these cancel, right? 2 over 2 is 1, minus the length. Now, if you decided to divide the whole thing, it would be perimeter minus 2 lengths over 2, which is a fair answer as well. Okay, they're both the same thing. This is a little slightly more reduced, but to actually like solve any of this, you would have to reconstitute this denominator. You know, it's just a lot. So if you left it like this, I'm totally down. This is fine too. All right, let's take a look at a couple more. Number 11, we have x over 4 minus 5 equals 10 over 3 minus x over 12. All right, we need to clean up these fractions, right? 12 is my largest denominator, so that's what we're going to start with. Does 4 go into 12 evenly? Yes. Does 3 go into 12 evenly? Yes. So I'm going to multiply every term. Remember that negative belongs to that 5. By 12. Remember this negative belongs here. So I'm multiplying every term by 12. Now, if you wanted to just multiply this entire side by 12 and distribute, blah, 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 totally the same exact thing. Go ahead and do that. So 12 divided by 4, we're going to reduce here. 4 goes into 4 once. 4 goes into 12 3 times. So now I have 3 times x, 3x. 5 times 12 is 60, but it's a negative, so it's minus 60. Here, 3 goes into 3 once, but it goes into 12 4 times. 4 times 10 is 40. And here, 12 divided by 12 is 1. Piece of cake. So this is just minus x. Now, I have an x on both sides of my equal sign. I need to bring them together. 3 is larger, so this x is the one that's going to move. All right? Because it's being subtracted, to move it, we need to do the opposite and add. Because I want to get x by itself, we need to handle this outlier. 60 is being subtracted from our x value, so we are going to do the opposite and add 60 to both sides, okay? These cancel, 3x plus x, how many x's do you have? You have 4 x's, is equal to 40 plus 60 is 100, all right? Here, 4 is being multiplied by x. We need to do the opposite and divide both sides by 4. X is equal to 100 divided by 4, or 25. All right? What about number 12? Well, here we do need to distribute because it is what it is. Or we could multiply both sides by 2 over 3, but that's going to make it a whole lot messier than it needs to be. Okay, like I said, there's always more than one way to handle things, but distributing, because this is a 2 and these are both even numbers here, we can do that a lot easier. So my 5x isn't going to change for right now. 5x is going to be equal to 3 halves times 8, okay? 2 goes into 2 one time. 2 goes into 8 4 times. So then it's 4 times 3, or 12, right? Or you could take 3 times 8, which is 24, divided by 2 is still 12, okay? In this case, when we multiply 3 halves times a negative, I'm just going to drop that negative right there, a negative 2x, the 2 over 2 cancels, and so we just have the 3 times the x. Okay? Or you could multiply 3 times 2, which is 6, divided by 2, which is 3. Again, same thing. Now, we have an x on both sides of the equal sign. The 5x is larger, so we are going to move this negative 3x. It's being subtracted. We're going to do the opposite and add. They cancel out. 5x plus 3x is 8x's equals 12. 8 is being multiplied by x. We're going to do the opposite and divide. X is equal to 12 over 8. 8 obviously doesn't go into 12 evenly, but they do have something in common, right? They have 4 in common. So we're dividing the whole thing, each numerator and denominator, by 4 to reduce. 4 goes into 12 3 times. 4 goes into 8 twice. And so our answer is x equals 3 over 2. You do not need to write 1 1/2. 3 over 2 is fine. When we start graphing things and whatever, changing it to a mixed number only makes it harder. So just leave it like this. As long as you've reduced your fraction all the way, you can just leave it in this form. Okay? That's lesson 7. Go ahead and finish the rest of the homework problems, and I will meet you for lesson 8. Lesson 8 begins on page 29, and it's titled Solving and Graphing Inequalities. It tells us here that a number line represents the entire set of real numbers. And for us to remember, reviewing our number line, we know that the number to the right is always greater than the number to the left. We go from left to right, but smallest to largest, okay? So looking at example 1, graph the solutions, and they wrote the word and here, but they really kind of want them on 2 different charts. Usually when you see the word and, we're combining them together, but in this case, they want them on separate lines. So first we're graphing the solution. X is greater than 3. Here's our number line. We put an open circle, and what that just means is just a circle that we don't fill in. We put an open circle at 3 because even though we're starting at 3, 3 is not included in this equation, right? X is not equal to 3, but it's everything greater. So it's 3.000001 is included, but not 3. So we put the open, what they call an open circle, and then we draw our arrow in the direction in which that solves our equation, right? Greater than means to the right. Now for the equation x is greater than or equal to 3, because the 3 is included, we draw what is called a closed circle, basically a dot. We fill our circle in, and then we still draw the arrow to show which direction we are including in the equation. All right? Now, at the bottom of page 29 here, we have some properties of inequalities. The first is the transitive property, and it tells us if A is less than B and B is less than C, then A must be less than C, right? If A is -9, B is 0, and C is 8, A is less than, or -9 is less than 0, 0 is less than 8, so -9 must be less than 8, right? That's all that's saying. For the addition property, it's similar to the one we already went over. If A is less than B and then we add the same number to both A and B, it stays the same. The problem, or the number on the left-hand side, is still less than the number on the right. For the multiplication property, it says that if A is less than B, and as long as C isn't 0, and we multiply that number by both A and B, then the equation stays the same. The A side is still less than the B side. The only time that isn't true, because here C had to be greater than 0, right, is if C is less than 0. If C is less than 0, then it's a negative number, and we multiply, when we multiply inequalities by negatives on both sides, then we have to flip the symbol. So here was a less than, it became a greater than. They're going to repeat this again. It's very important for you to remember this. They're going to repeat it again on the next page, but then we're going to talk about why that happens. So remember that inequalities only compare the values of two unequal expressions, right? We know that they're not the same, but they're either greater than, less than, greater than or equal to, or less than and equal to. But it says again, when multiplying or dividing both sides of an inequality by a negative number, the inequality symbol must be reversed so the statement remains true. Here's an example. Number 2. 3x minus 13 is less than or equal to 27 minus 2. We need to solve this, right? The 3x is larger than the 2x, so the 2 is going to get moved. It's negative 2x, so we're adding a 2x to both sides. We need to deal with the outlier here. 13 is being subtracted, so we're going to do the opposite and add 13 to both sides. Okay, so we have 5x is less than or equal to 40. I guess this one isn't a multiplying, a negative one, but number 3 is. 5 is being multiplied by x. We're going to do the opposite and divide. When we divide both sides by 5, our 5's cancel, and we have x is less than or equal to 8. Okay, so most of these equations, when we have a less than or equal to or whatever kind of inequality, we solve it almost exactly like a regular equation with the equal sign. It's just that we've got a less than or equal to sign, or a greater than or equal to sign, or a less than. But when it's a negative, we've got to do a little bit of extra work. So for this problem, we have negative 3x minus 2 is greater than 13. We're first going to start with this outlier. 2 is being subtracted, so we're going to do the opposite and add 2 to both sides, okay? So those cancel out. We have negative 3, and now is greater than 15. Negative 3 is being multiplied by x. We are going to do the opposite and divide both sides by a negative 3. When we divide that, and here's what I like to do, they've already switched it over before they actually did their division, but I like to draw an arrow through like this, so I remember to flip it around. So when we divided by that negative 3 over negative 3 is 1, so our x is now positive. Our variables, when we're solving these equations and we get our variable by itself, it needs to be positive. 15 divided by negative 3 is negative 5. They swap the sign, but here's why that needs to happen. If you're to think about it like this, we're at negative 3x is greater than 15, right? If we need this variable to be positive, because we do, that's how math is, and we did think about it like this. If we added 3x to both sides, right, it's negative. We want it to be positive, so we're going to move it like this. Now we have 0, because there's nothing left on this side, is greater than 15 plus 3x. We need to move this outlier. So we're going to subtract. It's being added. We're going to subtract it from both sides. Now we have negative 15 is greater than 3x. Then 3 is being multiplied by x, so we divide. So we have negative 5, right, is greater than x. If we were to just flip the whole thing around, keeping this point pointed at our x, okay, we get that x is less than. Negative 5 is greater than x, or x is less than negative 5. X is less than negative 5. These are the same thing. Both of these are exactly the same. We've just written it in a different order, which is what they end up with here when they just flip the sign. This is a lot more work, but this is what is happening and why we flip the sign, okay? This is the math that's going on that we are skipping, okay, just by saying, okay, flip the sign. So we saved a few steps. Let's take a look at some of these problems together. All right, so we're in Algebra 2, Book 1, Lesson 8, page 31. Problem number 1. 7 minus 4x is less than 15. Okay. Like I said, like we did in that other example, right? You could move your 4x to make it positive, but we are just going to work with the outlier for now. 7 is being added to our negative 4. We are going to do the opposite and subtract. 7 minus 7 is 0. So we have negative 4x is less than 15 minus 7, which is 8. Now, Negative 4 is being multiplied by x. We are going to do the opposite and divide both sides by negative 4. When I do that, I've got to change my sign. Okay? Negative 4 divided by negative 4 is 1. X is now greater than 8 divided by negative 4, or negative 2. Okay? That's what that looks like. Now we're asked to solve and graph, so I'm just going to do a super simple number line here. Here's my 0. Here is my negative 2. Here is my positive 2. I like to do opposites. X is greater than negative 2. It's not equal to negative 2, so I have an open circle. Greater than, if you have this equation set up with your variable on the left, the inequality symbol actually points the direction that your arrow should go. Okay? So all of these numbers on this side of the negative 2 are going to fit this inequality. Right? So that's what the graph would look like. Number 2, we've got negative 4 times the quantity x plus 4 is less than or equal to 8. Okay, first things first, we're distributing. Negative 4 times x is negative 4x. Negative 4 times 4 is a negative 16, which is all less than or equal to 8. Dealing with the outlier, 16 is being subtracted. We're going to do the opposite and add 16 to both sides. Negative 4x is less than or equal to 8 plus 16, or 24. Negative 4 is being multiplied by x. We're going to do the opposite and divide both sides by a negative 4. Because we're dividing by a negative, we need to switch our sign. So here we have x is greater than or equal to 24 divided by negative 4, which is a negative 6. Okay, switched our signs. Graphing this, we have 0. Again, we don't need to use graph paper on these line graphs. They are pretty simple. You do not need, oh, silly. You do not need to mark every single number. I got negative 6 there. 6 is here. X is greater than or equal to. Because it's equal to, we're filling in our dot. And then the symbol tells us which way our arrow is going to go. So that's how we graph that one. For number 3, 3x over 2 plus 3 over 8 is greater than or equal to negative 3 over 4. All right, we need to figure out our common denominator. We got way too many fractions. 8 is our biggest denominator. 2 goes into 8 evenly. 4 goes into 8 evenly. So 8 is our common denominator. So we're going to multiply each term by 8. Right? Here, 2 goes into 2 one time. It goes into 8 4 times. 4 times 3x is 12x. 8 over 8 is 1, so we have just a plus 3 left. Is greater than or equal to. For this one, 4 goes into 4 once. 4 goes into 8 twice. 2 times negative 3 is a negative 6. So now we have 12x plus 3 is greater than or equal to negative 6. We're trying to get this x by itself. We're going to deal with this outlier. 3 is being added, so we're going to do the opposite and subtract 3 from both sides. 12x is now greater than or equal to negative 6 minus 3, which is a negative 9. 12 is being multiplied by x. We're going to do the opposite and divide by 12. Here we're dividing by a positive, so our sign does not change. So x is greater than or equal to negative 9 over 12. Neither one of those go into each other evenly, right? But it can be reduced by 3's. There are 3 3's in 9 and 4 3's in 12. So x is greater than or equal to negative 3/4. So for our number line, here's my 0. All of these answers are negative, huh? Here's my negative 3/4. Here's a positive 3/4. Okay. X is greater than, oh no, they're all greater than. That's kind of funny. Greater than or equal to. Equal to tells me that I fill it in, and greater than goes to the right. And there's our graphing of that one. Taking a look at number 4, we have x is greater than 5 times the quantity x minus 4. We need to distribute our 5. So x is greater than 5 times x, or 5x. 5 times a negative 4 is a negative 20. Now, remember, we have an variable on both sides of the equal sign, but we want to move the smallest one. 5x is larger than x, and so we're going to move the x. Here, x is positive, so we have to do the opposite and subtract. Here, so this 20 is being subtracted from our variable term, so we are going to do the opposite and add. Right? Canceled, canceled. 20 is greater than 4x. Now, we want our x to be on the left-hand side, but all we're going to do is flip this whole problem over. So here it's, if we read it backwards, 4x is less than 20, okay? And that's just what we're going to write. 4x is less than 20. We haven't done anything crazy. All we've done is flip the whole problem over. We've like mirrored it, right? But it's exactly the same problem. So 4 now is being multiplied by x, or has been, and so we are going to do the opposite and divide, okay? When we divide, we get x is less than 20 divided by 4, or 5. Finally, we got a less than. Here's my number line. Here's my 5. Here's a negative 5. X is less than 5, so it's an open circle, and our symbol tells us which way our arrow should go. That's how you would graph that on the number line. Number 5. X minus 1/3 is greater than negative 10/3. Now, since our fractions here don't affect our variable and they have the same denominator, I'm not going to change up the fractions. This 1/3 is being subtracted from x, so I'm going to do the opposite and add 1/3 to both sides. These are canceled. X is greater than negative 10/3 plus 1/3, or negative 9/3. Now, that can be reduced, right? So x is going to be greater than negative 9 divided by 3, or a negative 3. Here's my number line, negative 3. Ooh, that got a little messy. Negative 3, 0, positive 3, okay? It's greater than, so it's an open circle at the negative 3, and we go to the right. Okay, number 6. 5x minus 7 is less than or equal to 35 plus x. I have an x on both sides of my symbol, right? My inequality symbol. So which one's smaller? The regular x. That's the one we're going to move. It's being added, so we're going to do the opposite and subtract. Here, my negative 7 is being taken away from my variable term, so I'm going to do the opposite and add to get it out of the way. X's become 0, my 7's become 0. I'm left with 5x minus x, or 4x, is less than or equal to 35 plus 7, or 42. 4 is being multiplied by x. We're going to do the opposite and divide. X is less than or equal to 42 divided by 4. Now, 4 does not go into 42 evenly, right? But we can reduce it by 2 at the very most. And so 2 goes into 42 21 times. 2 goes into 4 twice. So x is less than or equal to 21 over 2. Now, we're just going to leave it like that because I said so, and I'm a teacher. So we're going to graph our 21 over 2, and then here's a negative 21 over 2. X is less than or equal to, that tells me it's a solid circle, and that my arrow goes to the left. All right, so that is graphing on the number line. We solve our inequality, we slap it on a number line, okay? Go ahead and finish the rest of lesson 8, and I will meet you for lesson 9. Okay, lesson 9 begins on page 32, graphing linear equations. This is what we're going to need our graph paper on, and moving forward, we're going to need graph paper pretty frequently. A linear equation is an equation that has no variable raised to a power higher than 1. Okay, usually there's only 2 variables in a linear equation, but sometimes you can have 1, and I suppose, well, it's not really linear if it goes to 3 variables, honestly. But 2 variables, no squareds, no cubes. It's just an x or a y, okay? And it says the solution to a linear equation, linear meaning a line, are written as pairs of numbers in the order x comma y, coordinate pairs. Those can be plotted in a Cartesian coordinate graph, or I call it usually a coordinate plane. And we're going to take a look at what that looks like. So the coordinate graph is broken into quadrants, and the quadrants are numbered with Roman numerals from 1 to 4, beginning with this upper right quadrant, okay, where both your x and your y is positive, and moving counterclockwise. So 1, 2, 3, 4. It's kind of weird numbering system, but it's what we've got. This axis is the x. I see it's not labeled. The y-axis is labeled, but this is the x-axis. This is the y-axis, okay? And where they meet is called the center or the origin point, okay? The point 0, 0. It says to plot a single ordered pair solution, first find and place the x value, and then you find and place the y. So what that means is if we were to plot the point 4, -3, this is the x value and this is the y always, okay? That's why it's called an ordered pair, because they're always in the same order. So you would move over 4 and you would move down 3, okay? To the right is positive, to the left are negative values of x, up are positive values of y, and down are negative values of y. It's kind of like if you've ever played Battleship, okay? And you say B14, right? You've got to move over to the B line and then to point 14. So this is kind of the same thing. You're going over a positive 4 on the x-axis, and then you're going to the -3 on the y-axis, and you're putting your dot. That is this point, okay? Moving over to page 33. It says graphing by ordered pairs. It says to draw a line representing all of the solutions for a 2-variable equation, find at least 3 ordered pair solutions. Although only 2 points are required to define a line, 2 points create a line, we learned that in geometry. Finding the third point helps to ensure against errors, which is very true because any 2 points in space make a line, but that doesn't mean it's the line you're actually supposed to be solving for, okay? So we solve for 3 points. So when they ask us to find ordered pair solutions for a certain line, we will find 3 of them. I like to set mine up, and they kind of did it this way, in an XY chart, okay? If my x is a -2, in the equation, y equals x plus 3. If my x is a -2, so -2 plus 3 tells me my y is a 1. That is the ordered pair, -2, 1. If my x is 0, we're just substituting values in. 0 plus 3 tells me my y is 3. So the point is 0, 3. If my x is 2, 2 plus 3 is 5. So 2, 5. They plotted those points, and then they connected it with a line, arrows at both ends, because lines go on and on forever, amen. And then they even labeled it. Now, when we're only drawing one line at a time, you don't need to label the line. But when we start doing multiple, then we need to be clear which line belongs to which equation. Moving on. Graphing by using the x and y intercepts is another way to graph lines, okay? They've got an extra word here, but it says equations written in the standard form can be graphed by finding the xy intercepts and drawing a line through them. So the word to doesn't need to be there. The difference here is when you solve using coordinate pairs, right, or ordered numbers, ordered pairs, you want your equation in the form of y equals something. Here they're saying if your equation is in the standard form, ax, where a is just a number, by, where b is just a number, equals c, where c is a constant, okay? If it's in this form, you can solve by the x, y intercepts, where to solve the y-intercept, you make your x equal 0, because then the y is all that's left. And to find the x-intercept, you make your y equal to 0, because then x is all that's left. You find those 2 points. We'll turn the page and look at it. You find those 2 points, and then you draw a line through those 2 points. Now, obviously here we're only using 2 points, so we need to be careful with our math and make sure we are checking our work, because while any 2 points make a line, that does not necessarily mean that it's correct. Okay, so we need to make sure we're checking our work. Let's take a look at some of these problems together. Because we need to graph, I'm going to get out my graph paper. Okay, we're in Algebra 2, Book 1, Lesson 9, page 34. Problem number 1 through 3, they want us to find 3 ordered pairs and graph. Now, these equations, some of which are in standard form, this one is not in any form that we can work with, but to solve for the 3 ordered pairs, we actually need to get this into a y equals form, which is technically called the slope-intercept form. So we need to solve for y, is what we're saying. So here, x is my outlier. It's a positive, so I'm going to do the opposite and subtract x from both sides. So I have 3y is equal to negative x plus 9. Okay. 3 is being multiplied by y, so we're going to do the opposite and divide. But when we divide, we need to divide each term. Now we have 2 terms over here, right? We need to divide each term by that 3. And I get that y is equal to negative 1/3 x. I'm just taking the x outside of that fraction, okay? Plus 9 divided by 3, or 3. By taking this term outside of the fraction, it just makes it a little bit easier to work with, taking that variable outside, okay? Now, I'm going to set up my little chart here, x, y, and I'm going to choose 3 numbers for x. Now, because it's being multiplied by a fraction, I'm going to pick multiples of the denominator because that's going to make it the easiest way to solve. So I'm going to choose negative 3, 0, and a positive 3. There are my 3 x values that I'm choosing to solve for. It's not giving us, well, let me double check. No, it doesn't give us x values to use, so you can honestly pick any ones you want. I'm just going to pick the ones that I think are the easiest. You can make it hard for yourself all day long if you'd like, but I'm picking easy ones. So to solve for this one, I have y is equal to negative 1/3 times, instead of x, I'm going to put a negative 3 plus 3. Negative 1/3 times a negative 3, well, the 3's cancel, the negatives cancel, it's just a 1, right? 3 over 3 is 1. Negative times negative is positive. So this becomes a 1. I have 1 plus 3, or 4. So my first ordered pair, where can I write these? I've kind of squeezed myself a little bit. My first ordered pair is negative 3, 4. Okay. My next one, y is equal to negative 1/3 times 0, okay, plus 3. Well, any number times 0 is 0, so y just happens to be 3. So when x is 0, y is 3. And my last one is this positive 3. So y is equal to negative 1/3 times a positive 3 plus 3. Now, these still cancel to become 1, but this negative doesn't get to cancel this time. So it's a negative 1 plus 3 gives me a 2. So that ordered pair is 3, 2. Now I can graph them on my piece of graphs paper here. Since the 4 is the biggest number, I want to make sure I can, get to that 4. Okay, there we go. I set up a basic coordinate plane. You do not need to label every little dot. As long as your boxes are being counted as 1 point, I will understand what you're doing. So first, x is first, right? So this is a negative 3, which tells me I need to go 1, 2, 3 points this way. And then I have a positive 4, so I'm going up 4. 1, 2, 3, 4, and I put my first dot. My next point is 0, 3. 0 means I'm not moving to the left or right at all. I'm staying right here on this y-axis, but then I'm going up 3. 1, 2, 3, and I put a dot there. And my next point is at 3, 2. I'm going to move to a positive 3 value of x and a positive 2 value of y and put a dot there. Now we're going to pull out our straight edge and connect the dots. Remember that lines have arrows at both ends because they go on and on forever. Amen. And now we have solved for 3 points and graphed our line. All right, let's take a look at number 2. 2x plus 3y equals 6. Now, we could solve this with the xy intercept because it's set up perfectly, but they've asked us to do the 3 points, so we need to solve for y and get it into slope-intercept form. 2x is being added, so we're going to do the opposite and subtract. 3y is equal to negative 2x plus 6. 3 is being multiplied by y, so we're going to do the opposite and divide every term by 3. Y is equal to negative 2/3 x plus 6 divided by 3, or 2. All right, so there's our y intercept form. Let's solve for our points. Make my little chart here. And again, have a fraction here. I'm going to use the same points as I did in the last one. Negative 3, 0, positive 3. Because my denominator is 3. So for the first one, I have y is equal to negative 2/3 times negative 3 plus 2. Well, here my 3's cancel, my negatives cancel, because negative times a negative is positive, right? So I have 2 plus 2, or 4. So my first ordered pair is at negative 3, 4. For my next problem, I have y is equal to negative 2/3 times 0 plus 2. Well, any number times 0 is 0, so I'm left with just the 2. 0, 2. And finally, I have y is equal to negative 2/3 times 3 plus 2. My 3's cancel. Negative 2 plus 2 is 0. So I have the point 3, 0. Again, graphing my line. Set up my coordinate plane. And let's take a look at our first point. Negative 3, 4. X value is negative, so I'm going to the left. I always start at the origin, but I'm going to the left 1, 2, 3. And then my y is positive 4, so I go up 1, 2, 3, 4, and my dot. 0, 2. Okay, again, my x, it doesn't change, but then I need to go up 2 for my y, positive 2y. And then I have 3, 0. So my x is a positive 3, so to the right, 3 points, but my y is a 0, so I'm not going up or down at all. And so my dot ends up being there. Grab your ruler. And you connect your points. Grab your straight edge. There you go. That's the line represented here. Okay? Number 3. 2x equals y minus 1. Okay, I'm going to rewrite this as y equal, or sorry, not y equals, but y minus 1 equals 2x. All I've done is flip the problem over. I want my y on the left-hand side. I didn't change anything. I just took everything on the right and put it on the left, took everything on the left and put it on the right. Piece of cake. So we need to solve for y, though. Y is being subtracted, or 1 is being subtracted from y, so we're going to do the opposite and add. So we get y is equal to 2x plus 1. Now we're ready to go. Here's my x, here's my y. Because this is a whole number, okay, we don't have to choose anything fancy, so I'm just going to choose a negative 2, a 0, and a 2. Just so that I can get something on all sides of the equal sign. Or, sorry, something on all sides of the vertical y-axis, okay? So, y is equal to 2 times negative 2 plus 1. 2 times negative 2 is negative 4, plus 1 is a negative 3. So my first point is at negative 2, negative 3. For the second one, y is equal to 2 times 0 plus 1. Well, 0 times 2 is 0, plus 1 is 1. So I'm at 0, 1. And I've got y is equal to 2 times 2 plus 1. 2 times 2 is 4, plus 1 is 5. So 2, 5. There are my three. Oh my goodness. There are my 3 points. My graph goes down like this. And my first point is at -2, -3. So on the x, it is -2. To the left, 2. My y is a -3. So then I go down 3. 1, 2, 3. And I got my dot. My next point is at 0, 1. Okay? 0 meaning I don't move left or right at all. +1, I go up 1. And my final point is at +2, +5. So I go 2 to the right. And then 5 upward. 1, 2, 3, 4, 5. There are my 3 points plotted. Got my straight edge. And I draw my line. Okay? Those are the first 3. Let's take a look at a couple more. Number 4 is x plus 2y equals 6. Now for 4 through 6, they want us to graph the following equations by finding the x and y intercepts. Okay, so let's check first that they're all in standard form of ax plus by equals c. Yep. They're all in standard form, so we can do our xy intercepts pretty easy. Now, to solve for our xy intercepts, I'm going to solve for my x first, which means I need to make my y 0. So what is my value of x when y is 0? Well, x would be equal to 6, right? If this were 0, 2 times 0 is 0, so x would equal 6. So there is my x-intercept. Then I do the same for the y-intercept, except this time I make my x 0. If my x is 0, then 2y would be equal to 6. 2 divided, we'd have to divide both sides by 2, so that y would be equal to 3. So when x is 0, y is 3. Now 6 is kind of a big number, so let me make sure I have enough space here. Looks good. All right, so my first point is at 6, 0, which tells me I'm going to the right 6. 1, 2, 3, 4, 5, 6, but I'm not going up or down at all. My second point tells me I'm not going right or left at all, but I'm going up 3. So those are my intercepts where they cross the axis of this coordinate plane. And then I just connect the dots. And there's my line. Okay. Number 5. 3x plus 2y equals -6. All right, so I'm going to, again, solve for my x first, which means I need to make my y 0, or that 3x is equal to -6. To get the x by itself, I need to divide both sides by 3, so that tells me that x is equal to -2. So there's my first axis, right, my x-intercept. For the y-intercept, I'm going to make my x value equal to 0. So this one cancels out, and I'm left with 2y is equal to -6. I have to divide both sides by 2, so y is equal to -3. Okay, let's graph this. I can make it quite a bit smaller. -2, 0. So my x value is a -2, so I'm going to the left, but I'm not going up or down. 0, 3, that tells me I'm not going right or left, but I'm going down to a -3. Connecting these dots looks a little something like that. Right? Last one, number 6. 5x minus y equals -5. Okay. X-intercept means my y needs to be 0. So it tells me that 5x is going to be equal to -5. Dividing both sides by 5, I get that x is equal to -1. Making my y-intercept, or finding my y-intercept, tells me I need to make my x 0. So now I have -y is equal to -5. we need to remember here that we need our variable to be positive. We always solve for a positive variable. So because they're both negative, we're going to basically like multiply or even divide by a -1, which means we just change the sign of both sides. So y would equal 5. So graphing that, need a little bit bigger graph. My first point is at -1, 0. So I'm going to the left 1, but not up or down. So there's that point. And my second point is at 0, 5. Not going right or left, but I'm going to positive 5. 1, 2, 3, 4, 5. Okay. Very, very steep slope. And we connect that, right? So this is how you solve for your XY intercept. It's pretty straightforward. To solve for your x-intercept, you make your y 0. To solve for your y-intercept, you make your x 0 and then solve. And then plot those 2 points and connect the lines. Okay? It's not as precise as solving for 3 points, but it is, as long as you do your math correctly, gets the job done. Okay? Go ahead and finish lesson 9. That's the end of this video. When you're done with lesson 9, make sure you take your quiz 2 that was handed out to you in class. If you have any questions during the week, please don't hesitate to contact me. Otherwise, until next time.